In this video, we're going to be taking a look at quadratic relations in the form of y equals a bracket x minus r squared bracket x minus s squared bracket, aka factored form. Okay, let's jump right in with our learning goals. By the end of this video, you should be able to 1. Recognize and understand the key components of quadratic equations written in factored form, and 2. Describe and sketch the graph of a quadratic in factored form. So let's talk about the key components of a quadratic equation when it's in factored form. Y equals a x minus r x minus s. So what exactly does this mean? Well, first of all, it's important to know that any relation in factored form is quadratic, right? This does not look like what we were doing in earlier videos when we were working with linear equations, right? Y equals mx plus b. That's not this, okay? Another part, let's grab a color here. Another component, I should say, is what r and s represent. So r and s. So these are the x-intercepts. Which is also known as the zeros. So if you hear zeros, that's what they're talking about. Are r and s. I think it may be helpful if I draw what's going on as well. Let me get that out of the frame there. Just so you can visualize it a little bit better. So I'm going to draw a parabola here. So anything that's quadratic is going to be in the shape of a parabola. Quadratic and parabola are basically interchangeable. So the parabola is just the shape that the quadratic takes. So let's draw a parabola here. Ooh, I didn't know I could do that. Procreate just fixed my shape. Oh my gosh. Guys, I'm so excited about this. Okay. So we've got a point over here and a point over here. This is R0 and this is S0. So that's why they're called zeros, because at this point where the parabola is crossing the x-axis, y is equal to 0 here, right? The y value is 0, so that's why they're called zeros. Another thing to know is that the x-coordinate of the vertex is on the axis of symmetry. We know this already. Right? We explored this when we were looking at vertex form. So in this case, the x-coordinate of the vertex is on the axis of symmetry, and we're able to find the vertex, we'll just say v, equals, by taking the r-coordinate, adding it with the s-coordinate, and dividing it by 2. The reason that we're able to do that is because between here and here, trying to just make it a little more neat. Okay? This midpoint is the axis of symmetry, and we know that our axis of symmetry is going to give us the x-coordinate of our vertex, which is this point right here. So let's just do a quick example. Let's just say r was, let's see here, 1, 2, 3. So r is -3, and this one, 1, 2, we'll just call that 3 because it's got to be symmetrical. I just didn't draw it too neatly, that's all. Okay, so if we substituted that in over here, we could try to do that. So -3 plus 3 divided by 2. -3 plus 3 is 0. Divided by 2 is still 0, right? So we know that our x-coordinate of the vertex is going to be on 0. And it is here. So if you are able to look at this equation and say that is factored form, you're able to recognize that as opposed to standard form and as opposed to vertex form, right? We have our standard form, and we also have vertex form. So if you're able to look at all three of these and know that this is factored form, and you know what R represents and you know what S represents, then you're well on your way to achieving this first learning goal. You should know as well that A also has to do with this should look familiar, right? If A is positive or negative, it's going to determine if the parabola opens up or down, and it's also going to determine, what's the second thing that A determines? A stretch or compression, right? So if you can look at factored form and identify that it's different than the other two and identify the components of it, then you're on the right track. I will make a separate video that talks about standard form, factored form, and vertex form all in one. Okay, so let's just focus on factored form for now. So now we're going to move to our second learning goal, which is describe and sketch the graph of a quadratic in factored form. So let's put it up. I'm just going to move this up a little bit so we have some more space. There we go. Perfect. Okay, so it says describe the graph of the quadratic relation, and it's given it to us. And then it's asking us to sketch the graph and label the x-intercepts, the vertex, and the axis of symmetry. So I'm going to write this up here for reference. Okay? So, what are the x-intercepts in our quadratic relation? This is our quadratic relation that we're working with. Well, I see I have a +1 and a -7 here. Now, if you remember when we were dealing with vertex form and the h value, do you remember about that? And when we saw the h value in the brackets, if we saw it was negative, it was actually positive. And if we saw it was positive, it was actually negative. Well, the same thing is happening here, because if you look, in order for this value to equal +1, what do we have to put inside here to change this negative to a positive. Well, that would have had to have been two negatives. So I know that my x-intercepts are actually -1 and +7. So far, we have found the x-intercepts, which are right over here. Now let's find the vertex. So because parabolas, I need a different color, are symmetrical, we can use these x-intercepts to help us find the axis of symmetry, which is also going to help us find our vertex, right? So let me see if I put a graph up here. Perfect. Okay, so if I know that one of my x-intercepts is at -1 and 0, and the other one's at +7, 1, 2, 3, 4, 5, 6, oh, this is just big enough, excellent, 7, I know that my vertex has got to be directly in the middle of these 2 points, okay? The x-intercept of my vertex. So what we can do is to find the vertex, we'll take -1, we'll add 7, and we'll divide it by 2. So v equals 6 divided by 2, v equals 3. So I know that my vertex, the x value of my vertex, is going to be 3. Okay, but what about the y value of my vertex? I can't just guess somewhere randomly, oh, that looks like the middle. That's not how it works. But now that I've been given x, if we look back at our original equation here, now I've been given x. So what can I solve for? Y. Let's do that over here. All right. So y equals 2, 3 plus 1, 3 minus 7. All right, so now let's simplify and solve. That equals 4 and -4. And when I multiply everything, I get -32 for my y. So that means my vertex is going to be all the way down here somewhere. My scale is not to proportion, but we'll just put it there. 3, -32. So now we've found our vertex. And then for the axis of symmetry, well, we know our axis of symmetry is just the x-intercept, the x value of our vertex. So this, we already found that, right? Okay. Now I'm going to sketch this, or attempt to, right? And we know it's got to stretch because we see a value of 2 here, and when a is greater than 1, if we remember our rules, it causes a vertical stretch. Depending on how you're feeling about this, you may want to review the video about standard, factored, and vertex form in order to help you better visualize how we deal with quadratics. Almost in the same way that we did linear relations in regards to graphing and doing the method of substitution and doing the method of elimination. That was all different kinds of ways to analyze linear equations. We're doing the same thing with quadratics here, except we're looking at factored form, standard form, and vertex form. They all produce a parabola, the shape of a parabola, as opposed to making the shape of a straight line. So I'm going to go more into depth in that in a separate video, so please give that a watch and then come back to this one and review the concept again.